All right, so today we complete our lock in. All right, so today we complete our gas law journey. First, we are going to talk about the third individual law, and then we will roll that into the combined law that we started with what feels like forever ago, but it was in fact just Monday. No, it was Tuesday. I don't know, whatever day it was. So today is Gay-Lussac's law. This guy has the shortest list of accomplishments. He is not into balloon animals, nor is he a gentleman, apparently. I think he'd probably be upset. He's just French. He's a chemist and a physicist. So he did the final pairing of gas properties, right? We've had Boyle's, which was pressure and volume. We then had Charles's law yesterday, which was what two? What two properties of gas did we look at yesterday? No, not pressure. Temperature and volume. So, spoiler alert, the only pairing that we haven't messed with so far are pressure and temperature. And that is what we are doing today. Now, you'll notice the formula for these, pressure and temperature, follow a similar looking formula to yesterday. So what kind of relationship can we infer from pressure and temperature? Direct relationship. As one gets higher, the other gets higher. As one gets lower, the other gets lower. And you guys intuitively can figure this out. If you put a pot of water on the stove and sealed it up real tight and started heating it up, what would happen next? Yes, it would heat up, but what else would it do eventually? Not boil, if it's sealed. Like we sealed it up. It would explode. Why would it explode? Yeah, so as that temperature builds, the pressure would also build until finally you're going to have a bad time. This is how a pressure cooker works. For those of you that have ever, I don't know, worked with a pressure cooker.
Oh, is that why you have to pop the top off?
That is, slowly. You have to release that slowly because there's pressure built up because you heated it up and the water expanded and away you went. So that is Gay-Lussac's law. Now, because we are using temperature again, what asterisks are we going to have here? What additional detail, similar to yesterday, are we going to have to make sure is correct? What did we have to do yesterday with temperature? Yeah, we had to use Kelvin units. You have to convert to Kelvin to do the math for this law, just like yesterday. And as far as pressure is concerned, just like we had with volume yesterday, you have to make sure you're using the same unit. So if pressure on the left is in atmospheres, pressure on the right must also be in atmospheres. So you carry the same units across. When using temperature for these calculations, you must always use Kelvin units. And we have the conversion for that. You have that in your notes. You used it yesterday. So that's it. The only thing left is to put all of these things together. We're not going to do the example. You know what? I don't like this one either. Let's get rid of this. Exit. This is the combined gas law. Add a gentleman, a balloonist, and some French guy together, and you end up with the combined gas law. Now for this to work, one caveat here, you have to be given 5 of these variables to calculate the 6th. You can't leave 2 out there because there's no way to specify which one those are. You also need to use all the same units. So whatever you use for pressure, whatever you use for volume, those have to also remain consistent. And then lastly, just like before, for temperature, you have to do these calculations with Kelvin units for temperature. So all of these things are how we can use this combined law. What you'll also notice here, to go back in time, if you keep any one of these the same, you end up with the accompanying law. If you got rid of volume on both of these because it was the same number, what does this law then look like? Yeah, no. It's the one we just did today. Okay, Lussac. If you got rid of temperature, what law is that? The first one, Boyle's law. And lastly, if we were to get rid of pressure, this would be yesterday's Charles' law.
It's like that triangle thing.
That's been banned in this classroom. Any mention of the shape of triangles. Rhombuses are fine. Even a hexagon would be allowed, but no triangles. Only somebody who had taken physics would understand the anti-triangle ban in our classroom.
Why do you not like triangles?
Reasons. So this literally is it. And again, the difficulty here is not the math. The difficulty is not the math. This is all simple algebra. Converting from Celsius to Kelvin and back and forth is a simple formula. Solving one of these once you have 3 out of the 4 variables is simple algebra. The difficulty here is reading the question, knowing what is what. The difficulty here might be remembering to transfer or to convert units from Celsius into Kelvin. The difficulty here might be seeing something that says you went from 720 torrs to standard pressure and having to fill in, well, what is standard pressure? Standard pressure is 760 torrs. And filling in the blank on that. But otherwise, this whole unit has really been pretty simple. It's just different combinations of these properties of a selection of gas. Questions on any of this stuff? Helgeson?